Okay, we can use the complex exponential to multiply and divide complex numbers together. So here I've got two complex numbers, and I've written them in modulus argument form. So if you've got two complex numbers in Cartesian form, you can convert them into modulus argument form. You know how to do that. And I'm going to equate these to their exponential definitions. So this is going to be equal to R1 e to the I theta 1, and this is going to be R2 e to the I theta 2. Okay, that's just using the exponential definition of a complex number. And now what I can do is I can multiply those together. So if I wanted to do Z1 times Z2, then that would be equal to R1, R2, e to the I theta 1, e to the I theta 2. But of course, if we're multiplying two exponentials together, we can just add the exponents. So it's going to be R1, R2, e to the I theta 1 plus I theta 2. And then finally, we can factorise out the I from the exponent. And we're left with this. Well, what is this? Well, it's another complex number, as you would expect. So you multiply two complex numbers together, you get another complex number. But it's a complex number such that the modulus is equal to the product of the moduli of the two original complex numbers. So this modulus was R1, this modulus was R2, and the modulus of our new complex number is R1 times R2. The argument is also changed. So the argument of this complex number was theta 1, the argument of this complex number was theta 2, and the argument of the new complex number is theta 1 plus theta 2, because that is the coefficient of I in the exponent. So essentially, what that says to us is when we multiply two complex numbers together, we multiply the moduli, which is the plural of modulus, and add the arguments. Of course, by adding the arguments, if you then go out of the principal range, so say you go greater than pi, you would need to subtract 2 pi from that to bring it back into the range. But it's not a major issue. Okay. We can also prove the same thing using the product of these two, but you'll need to use some trigonometric identities which you've not been taught yet. But we can come back to that later on. I can show you it works there too, if you want to. Okay. Any questions so far? Brilliant. We can also use the same kind of principle to divide. So what do you think is going to happen when we divide two complex numbers? Yeah. Similarly, when we divide two complex numbers, we divide the moduli and subtract the arguments. Okay, that one, it matters the order in which you do it. Okay, you've got to make sure you get it in the right order. Okay, so Z1 divided by Z2 is obviously not the same as Z2 divided by Z1. That's going to equal R1 divided by R2 times e to the I theta 1 subtract theta 2.